The next index mineral we're going to talk about is garnet, and garnet is one of the most common metamorphic minerals. There's also a lot of garnets. So notice in this chemical formula here, you see that A3B2. That's because there's a lot of different elements that can fit into those A and B slots. So those that are rich in iron are known as almandine, and they are super common in metamorphosed igneous rocks. Those that are rich in calcium are called grossular, and they are very common in metamorphosed carbonate rocks. Okay. So you've noticed in class that we have samples of both red and green garnet. That's because we have both almandine and grossular garnet. Right? Now, the highly variable chemical composition of garnet means that there's a lot of different end members, right? Again, as I said, those A and B sites there can be filled in by a lot of different combinations. That A can have calcium, magnesium, or iron. The B can have, A can also have manganese. The B can have aluminum, iron, or chromium, right? There's a lot of different combinations here. And that means there's a lot of different end members, 6 of them. The 3 end members at the top, we call those the pyrrolspite group, and the 3 end members at the bottom, we call the eugrandite group. So notice that red almandine is in the pyrrolspite group, and the green grossular is in the eugrandite group. And the reason we group them this way is because there's not a lot of mixing between these 2 groups. So notice on this ternary diagram that the entire eugrandite group exists at the lower end, right? There's a lot of calcium, there's some aluminum and some iron, but there's never going to be any magnesium or manganese in this eugrandite group. And it's the opposite for the pyrrolspite group, right? They're going to have a lot of manganese and magnesium, but they're never going to have any calcium in them. Right? And there's not a lot of mixing between these 2 groups, right? So there is solid solution mixing within a group, right? So the different types of garnets within a eugrandite group can have a lot of mixing between them, but you're never going to see mixing between eugrandite and pyrrolspite groups, right? There's that immiscibility gap in between those 2. But like I said, within a group, there can be some mixing, right? So andronite, right, could be a little bit of grossular. There could be some solid state solution mixing in there. All right, some more properties about garnet. Regardless of what garnet it is, whether whatever group it's in, it's always going to be isometric, meaning there are 3 planes all at 90 degrees to each other that are all exactly equal in length. They're commonly dodecahedral, meaning they have 12 sides. They're relatively hard, which is one of the reasons we use them economically as an abrasive, like a sandpaper, but they're pretty, so we also use them for jewelry.